Good morning, everybody. So today I want to talk about AWS security. This talk will be a checklist style talk. So I'm going to talk about a bunch of the kind of areas and services AWS offers. And I'm going to give you a bunch of checklists of things to go do. So this will be very actionable. Some of the things you can try while you're at CodeMash, they're pretty passive. They just give you an idea of what's going on. Some of them may take a little longer. So obviously take everything, what I say with kind of a grain of salt and make sure it really fits in your environment. But one thing before we get into the kind of scheduled talk, is kind of the elephant in the room. Who has not dealt with this yet? Who does not know what this is? All right. So recently there were a series of vulnerabilities released called Spectre and Meltdown. These are incredibly important to fix if you are in a cloud environment. All of the security in the cloud is predicated upon the hypervisor working and not leaking your stuff into other people's instances. So this breaks that. So really, really, really important that you fix that. If you haven't dealt with that, I will have no hard feelings if you leave and don't do that now. So like today, kind of fix it if you haven't dealt with it yet. It's really pretty serious. But back to, what we want to talk about. So a couple things, just to kind of get an idea. How many of you are already in AWS, Azure, GCP, something like that? Majority. How many of you are thinking about going there, not quite sure yet? Or not allowed to yet for security? Yes. So I need to shatter some of that, and then we're going to talk about some interesting ways to keep yourself safe, right? There's tons of reasons to get there. I will argue, modulo the events of the last week or so, that, a service like AWS is actually safer than running your own data center. For some of the reasons I'm going to talk about now, but, for some of the kind of even foundational reasons of knowing where things are at and what you have. But there's one thing about, kind of moving to, a cloud hosting provider that there's a lot of misconceptions, basically, right? And what I'm going to talk about will apply to Azure, it'll apply to Google, it'll apply to Amazon, but I'm going to talk about Amazon services directly. So it'll map kind of one-to-one there. But there's a lot of misconceptions on how to approach security in one of these environments. It is different. It is not the same as your own data center. Like I said, I'm going to talk on AWS, but the concepts really apply everywhere. The first thing is it's very easy to get caught up mirroring your data center. How many of you have had a data center and are either moving or have moved out of your data center and into AWS? How many of you took what you had in a data center and booted up in AWS? Yeah. So this is a really common thing to happen. This is totally anti-pattern. If you're doing this, if you have done it, if you're in the middle of thinking about doing it, don't just lift and ship what you have and stuff it in Amazon. That's going to leave you with some gaps. So really important not to just take what you have and boot it up. Moving here means thinking differently, right? This is not a traditional data center, and you shouldn't treat it like one. It's really important that you don't treat, the Amazon resources as what you currently have. There's a lot of assumptions that we make about a data center, like, nobody can access it unless they're on the network. That we might have physical access to the machines. Things like that used to exist don't anymore. And the way we design our systems around that is different, and you should treat it that way, right? Now, there are some aspects you may want to keep, and we'll talk about those too. But definitely some things you want to throw away. So to get it right, to really get the security in the cloud right, it does require some change. A little bit of mental model shifting, a little bit of thought change, but you want to understand kind of what those are, right? So I have a few key areas. This talk is going to talk about, first of all, automation. I know it's not directly related to security, but it's incredibly important for it. IAM, user management, how we design our networks, how we deal with encryption, how we audit our environments, and then how we do CI and CD and all of that, kind of alongside in the Amazon environment. So first things first is automation. Before I talk about automation, I'm required to show this slide. This slide has a lot of truth in it, to be honest. When we started this whole thing, when Amazon came out, when Azure came out, when Google came out with their cloud environments, we all went, yes, let's just, boot some stuff up. And that's what we all did. And we were left with a pretty big mess. It was pretty bad, right? Because we all had the power to spin up whatever we wanted to do whatever we wanted with them. And we made some mistakes. So this has been the way it was, but it's getting a lot better now, right? We've kind of moved into a model where we understand the mistakes we've made. The automation that we've created understands that we can bake the security into the automation, right? And so we're getting better, but we're still kind of shoveling some of this. So this part, though, the automation part in general, is a critical step. You've got to do this. At this point, there's no excuse for ignoring the automation part. You can't. In fact, the platforms are built for it. If you look at what goes on underneath Amazon when you click a button in the console, it's just an API call. Everything's an API call. This whole thing is predicated on automation. And that's how you should be running this environment, right? I'm going to go a step further. And I'm going to say that humans clicking buttons is actually what causes security issues. Full stop. If you're clicking buttons in the console, you're causing problems. That is, I know it's a lot to take in, but it's also a pretty serious thing, right? The minute anybody can log in and do this, you have something nobody understands or maybe knows about or is left behind, or isn't recorded, right? And when you have people clicking buttons, this is what causes blockers, it causes frustration, it causes slowdowns, right? So if you were in your DC model originally, right, and you had a bunch of operators where if you wanted a computer, you filed a ticket, and that person would take the ticket, and they would create an instance for you, and they would return back and say, okay, here's your instance. It was somebody that literally took a ticket and hit some buttons or typed a script, and then gave you your thing, right? They are what Amazon does. They can be replaced by simple automation, right? You want to eliminate that position. You want to eliminate whatever happens there, right? You want to replace all of that with just simple automation. What is simple automation? There are things like Terraform, CloudFormation, Ansible, any of these kind of tools get you there. It doesn't matter what. I have no horse in this race, don't care. Whatever is your favorite one, use that, right? And I will also say, if you desire to move to the cloud and you want to continue clicking buttons in a console, stay where you are. You're not going to get many benefits, right? The benefits really come from that rigorous automation, right? Because one of the big things in terms of security is that you shouldn't log into the console. There's no reason, right? In fact, you should page the security team when somebody logs into the console. Or just disable access entirely. And there's an asterisk here, right? There's a couple people who are going to need access in case things, right? But in general, this is not what you should be doing. Logging into the console is another one of those ANSI patterns. You shouldn't be doing it. You logging into the console is just an excuse to not automate something. Now, I'll say that getting your infrastructure and configuration into code is kind of that first step, right? This is the first step to better security. The reason why that is it allows for review, it allows for analysis, it allows for audits. If you have your systems automated, you check code in. What do we do when we check code in? Code review. What else might we do when we check code in? Run tests, CI, CD, right? Static analysis, right? All the things that we do that make our good development practices now become part of our infrastructure automation, right? We're pulling it into our normal workflow. And also, it creates a culture around describing systems as data. That's what we're doing. We're saying we're taking a bunch of data and saying this is our system. This is what it looks like, right? And what it fits well because the cloud is simply an abstraction, and we can just talk about it like one. We can talk about the abstraction, right? We're not talking about whether or not it's an Intel or AMD CPU. We're not talking about the type of network interface we're using. We're saying, hey, I want a computer, and I want it to have this much memory, and I want to have this much disk, and I want these many interfaces. We're talking about the abstraction. We're not talking about the machine, right? So we can use that code to just describe the abstraction, because that's all that actually matters, and that's all we have access to anyways. So we go up here, and we talk about it like that instead. And when we have the abstraction, we start to have interesting things like impact graphs, where things are, what happens when something goes wrong, right? When you talk about the abstraction, you talk about how things fit together, and you can do some really cool stuff, right? And what it does is it shifts the blocker out to just simple code review and static analysis, right? You can automate it and have your CI pipeline throw out a problem and reject a change versus having a series of humans go back and forth and talk about what's wrong while you wait for them to figure it out, right? That's kind of a pretty powerful thing, right? So my automation checklist. Like I said, every section I'm going to lead with a checklist. So the first thing, all your infrastructure is recorded as code. Step one. Any change you make is made by that automation. So you're not using the console anymore for anything, right? Console logins are restricted to just a couple of people, right? A few people who just really kind of need that admin access. Most important thing, I'm gonna say this over and over again in multiple sections, right? Teams are educated on what to do. You can't just turn this off and expect everybody to function properly, right? You need to give people tools. So when you do this, they need to be able to use the tooling. That could be using the automation directly. It could be scripts that you write that give people kind of a templatized version of what to do. So maybe you have a CloudFormation or Terraform templates for a computer that you just allow people to kind of go off of, and all they can do is change a couple of variables, and you have kind of control of the rest of it. Whatever that is, right? But teams have to be educated and empowered to use these tooling, because when you take the console away, you take their ability to function away. So you can't just turn it off and give them nothing. This is all about trade-offs, and we have to make that trade-off of education and awareness and good tooling first. Next comes user management. Identity and access management. This is really important. You have to get a grip on users and the permissions. How many of you have super admin or administrator access in AWS in the console? How many of you think you should? Wait, I saw more hands go up than you think you should, and you don't. If you don't, you shouldn't. Now, again, most of you don't, right? A few hands came up. I'm hoping you're the DevOps system administrators of the environment. Is that correct? I hear some wavering hands. No, you don't need it. You don't need it. All you need are the roles you need, right? If you really are truly operating that environment, then yeah, you need that administrator access. But again, that's a small group of people who actually need that. A lot of people that say they need that just don't understand what roles they really need. It's a trade-off, right? And I will tell you that I've seen some things. This is bad. This can get pretty frustrating. I walk into environments where everybody just has admin access to everything, right? It's just chaos, no control. And a mistake here can provide control over everything, right? How many times in the last couple of years have we seen a hack because somebody left an S3 bucket open? Right? Like, this has happened multiple times, and it's caused some pretty big damage. Or just something trivial, sounding simple that somebody forgot to do. All it needed was just a little bit of automation and review, right? But one more thing that's really, really important here is, and it's different than your data center, is if somebody gets your access keys, the things you use to log into the API, what can they do? Well, whatever you're allowed to do, right? Whatever you have permission to do. Where can they do it from? Anywhere. Total game changer, right? Because in your data center, it could only be if they were on your network. If you had your keys, they had to be on your network first. With AWS or any of these providers, that's not true anymore. They can be anywhere in the world, and as long as they have your keys, they can do whatever they want, right? So that just became way bigger. Loss of those keys is really damaging and can cause some pretty big issues, right? So again, never check these things in anywhere, right? Some of these issues are credentials got checked into code, they were stolen, from GitHub. They were a public repo on GitHub and got checked in, right? That's kind of good hygiene in general. Never check anything into a repository that is secret. But let's talk about how we get there, right? How do we get to that good place? The first idea really is use a directory. If you have a directory service at your company already, replicate it into the cloud and use that as your system of record. So if you already have that directory, use it. Not a problem at all. There are plenty of tooling in the environments that lets you replicate or just create a new directory in the cloud and have that be your system of record. You don't want multiple systems of record, right? You don't want to have a separate set of users for AWS and then your kind of corporate accounts, right? That's multiple systems of record. Because what happens when you do that and somebody leaves? You forget to turn off their access. How many of you have been there before? You look at Amazon and go, oh shit, they haven't worked here like 6 months. You hurry up and delete the account. They still have active access keys. But before you delete them, figure out when the last time they used those keys was, because it may be after they left. But having that system of record, that single source, right, with a directory means if they terminate, HR schedules termination, the offboarding checklist goes through, they deprovision the corporate, directory, and all of a sudden, they're just off, right? That's fine. It makes it nice and easy. It's one big sliding thing. It solves those onboarding and offboarding issues, right? You might have an OU that's an AWS OU in your directory that just says, oh yeah, if they moved here, they have access. And inside of that, you may have your own little forest there that says, oh, well, they're in the developers group, the administrators group, and that would, transfer over into different roles. You can even mirror the roles in Amazon and have that all kind of just cascade transparently. And it also ensures that changes in the directory propagate through to Amazon. So let's say somebody goes from development and they decide they're done with this, they're sick of all this nonsense, they want to go be in marketing. And they leave, they go to marketing. What should you do when they go to marketing? Remove their access to AWS because they don't need that anymore, right? And so you want, HR changes to just propagate through the system as, anything else. And so again, this is kind of powerful to use that directory. Now, you may not have a directory. Okay, no big deal. If you don't have one, I would suggest creating one. It's kind of nice to have that for lots of reasons, not just AWS security. But no problem, right? Make sure you have strong account requirements, though. Make sure you don't allow password reuse. Make sure your password strength is good. Make sure MFA is enabled. I'm going to tell that to you anyways. But again, you want to make strong requirements for passwords on that account, right? You can't control it through the directory. Make sure that's done right in Amazon, and it'll tell you. If you ever log into the console, it'll tell you, hey, your password's not very good, right? You're missing some steps here. One more thing here that's super important is the root account. So I have one simple piece of advice for you. Don't. Period. So the root account, how many of you are using the root account for something today? Logging into the root account, using root account keys. Stop, right? Page security when somebody uses the root account. This should be a pageable offense. Everybody should understand when this happens. There are only a handful of things that you should use the root account for. In fact, Amazon lists them. They're a little bit too many to fit on the slide, but this link has a link to all the things that are root account only things. In this list are things like requesting a penetration testing window. If you do penetration testing, you're going to have to ask Amazon permission, fill out a form. You can only do that the root accounts. If you're asking for things like AWS's SOC 2 report annually, or any of their certification and compliance things, that comes with the artifact service. That goes through the root account because they ask you to sign an NDA, and only the root account can legally bind the NDA. If you're doing certificate signing, it does the root accounts. So things like that, but things that they don't happen on a daily basis. They're one-off things. They're usually manual tasks. Only this, right? If it's not on that list, it's not acceptable to do it from the root account. You gotta break that habit. Now, I get it. We all have personal accounts. We do stupid things with them. But for your real accounts, never use this root account except for that small list of things. And the only permission an IAM account should have is assume role. Nothing else. The security token service should be the gateway to everything you do. Security token service is effectively a way to get short-term kind of scope credentials on something, right? So security token service says, here's my credentials. I want a token to create an S3 bucket. I want a token to modify Route 53 routes. I want a token to whatever, right, to do a thing. So effectively what you're doing is creating pseudo in the environment. Nobody has any permissions, and when you want to do something, you always assume a role to do a thing. This is a couple of things, right? It reduces the direct exposure of credentials because you're not using your credentials straight up. You're just using that token, right? So you can lock those credentials away and only use them for certain cases. There's a nice little tool called AWS Vault. It's a local tool. It actually vaults your credentials into the OS keyring, so it's not in a flat file on disk in plain text. And it automatically uses STS to assume roles and exchange everything for you. It's a nice little service, some bonus points. Right, but when you do this, when you strip away all the credentials, it actually forces people to think about the roles they really truly need to do a thing, right? For those of you who raised your hand and think you need administrator access, every time you do something, think about which role was the actual role you needed, right? Turns out a lot of people only need a few things, right? We only maybe create some buckets, maybe we spin up an instance, maybe we change some DNS, maybe we do an RDS instance here or there, right? That's about it though, or maybe a KMS key. And those are the only roles we'd ever need. Like you don't need, administrator access is every service on Amazon. All of them, right? How many of you use every single service Amazon offers? Nobody, right? That's insane. So yeah, you don't need that administrator access because you don't do all the services. So what you need is scoped and limited access. So my IAM checklist. First of all, the root account has MFA enabled. So you're going to have to use it eventually, but when you do, make sure it has MFA enabled. You have two choices here because you're going to have more than one person who needs root access. One is buy a hardware token and put it lock it up in a safe somewhere in the office, or have the QR code that you scanned by multiple people all at once when you create the MFA token so that everybody has it. If you use a tool like 1Password, you can vault the MFA token into 1Password, and it can go, kind of produce a token for you. But lots of different ways to do that, but make sure that root account has MFA access enabled. Make sure the root account has no access keys. If there are any active or live access keys for the root account, delete them and replace them with a provisioned user, right? The root account should not have active keys. Another thing is that users have no permissions outside of STS assume role. Now, one thing that's interesting when you do this, when you strip away all the permissions but assume role, what happens in the console? You can't do anything. You can't even read, right? The console becomes useless. So that whole habit of logging into the console disappears because they can't even read what's going on. It's just a bunch of really red boxes that says you can't do this. So you can log in, but it's totally useless. If you have a directory, it's replicated into AWS. MFA is enabled for all human accounts, right? So anybody logging in must have MFA enabled. Now, you can go even a step further, and you could kind of put a little barrier here, right? And you could say anytime you assume a privileged role, MFA is also required. So what you do is you create a role, and you allow a user to assume that role, and then you put a condition on the role that says, when assuming this role, MFA is required. And so that becomes a barrier. So then now you have that pseudo concept with MFA. Again, training and education. Users need to be trained on how to do this. You can't just make this work, right? If you don't have a tool to automate the STS role stuff, it's really painful. So you need to use a tool like AWS Vault, like the HashiCorp's Vault tool, something that basically automates and kind of makes transparent the whole STS role assumption thing. It should be able to just give you what you need and go. The scripts that you use to do things should just be modified to work with STS naturally, right? You can't make this a thing. If people have to think about this, they'll revolt and pitchforks will come out. So make sure you take a lot of time to educate people and provide them with good tooling. One more thing is strip those inline policies. We all have them. They're all dirty little secrets. But those inline policies that are, kind of fudged for, to try to make something work, get rid of those and make them managed policies. Next is network design. I'm gonna go really thin here, right? The reason is network design is situation dependent. We all have different needs. Sometimes we only operate in AWS in one VPC and that's it. Sometimes we have multiple regions, multiple VPCs. Sometimes we have a corporate data center and Amazon, right? I'm not going to give you patterns for all this stuff. We could be here all day. But there are a few things that do matter, and I want to talk about those. And the first is creating a boundary, right? You must create a boundary, right? And the boundary starts with a VPC. The VPC is that container for your world. You may have multiple VPCs, but really it's the container for your world. You want to isolate environments and scope inside of a VPC. What I mean by that is dev, staging, prod, right? Those are all different VPCs, different environments, and you want to segment them off, with their own networks. They shouldn't all be in one place. Make them truly separate. That way you don't accidentally shove things in the wrong place. Scope. Let's say you have a regulated environment, a credit card environment, a healthcare environment, whatever that is, right? Don't put all that in one big giant thing, because now when the auditors come knocking, that whole thing's in scope for the audit. Make a little tiny bucket, a little tiny VPC, isolate that thing off so that the only thing they need to test and audit is that little thing right there, right? You can use this to your advantage and segment off the things that are regulated or auditable. And you can kind of crank the knobs up on that one, right? The next thing is you want to monitor what comes in and out of that VPC. So VPCs have a flow log feature enabled. You can turn that on. Flow logs are, here's all the traffic coming in and out, and here's what happens. So you want to monitor what comes out. And you want to turn them on and put them into a place that can monitor and then tell you what happens. So not just a flow log monitor, but also something like a SIM that's going to see and maybe have some identification of an incident when it happens and let you know, hey, you normally have this much traffic going out. And today you had 100 times that traffic. Somebody's probably stealing some data, right? You want to be able to see what's going on. And you want to be conscious about the entry points. How do you get in? What you want to do is look and see how you get into that environment. What are the ways in? Now, you're going to have the standard, oh, I have a website, and you get in that way because that's intended. But for administrative purposes, there should really only be one way in. And you have a couple options for that, right? You can have VPN, or you can have Bastion or jump hosts, right? You don't want to expose the management of all machines directly, right? You have SSH on. Don't expose every single machine you have SSH to the world, right? It's a really bad idea, right? You're taking that footprint and making it very big. The footprint should be very tiny, right? The only external footprint you should have for remote access is that VPN server or that Bastion host. Maybe you have a couple just for redundancy purposes, but that one entry point in, and that's it. Everything else needs to be turned off publicly. And privately, you can have it all on. That's fine. But externally is just one piece of exposure. Use tools to report on the external footprint, right? I'm going to show you a couple tools during this talk you can use that will just give you a summary. But you want to know what that looks like, and you want to test all the time and make sure that doesn't ever change. So my checklist here is everything is inside of VPC, or multiple, right, separated by scope and environment. Flow logs are enabled and they're monitored. It's not good enough to turn them on. You actually have to put them somewhere and pay attention to them. So make sure you monitor them as well. Everything that can has a security group attached. Security groups are the firewalls of AWS. So if you can attach a security group to it so it has a network interface, you should. And make sure those are monitored, scoped, reviewed, and I'll talk more about that anyways. Any security group that allows access to the world has a description and a justification in it. Right? You can add tags to anything in Amazon. If you have a security group, add a tag. That tag should be a ticket in your internal ticket system, whatever you use, which is the discussion and approval for that firewall rule that allows everything to everywhere, right? Don't just open it up. Have some history there, right? So if somebody says, why does this rule exist? Then go ahead and put a tag. It's just a link to a ticket or just a ticket number, whatever you want. And make sure you have that referenceable so somebody say, hey, why did that happen? And then you look back and go, oh yeah, we had that discussion. These people approved it. We're good to go. Or you might say, hey, you know what? I think they were wrong. I'm going to challenge that assumption and maybe change it. But don't just leave that blank. Anything like that should have a justification. And again, remote access is only allowed via that single entry point, the VPN or Bastion hosts. All right, encryption. So, encryption. I want to take a moment just to acknowledge this is difficult, right? How many of you think you got encryption right? Thank you. Okay, good. Nobody raised their hands. Perfect. Because you don't, right? There are so many ways to get that wrong. And we can make choices that reduce the efforts to do encryption right. We can make choices that reduce the chance we make mistakes in encryption. But it's really tough to get right? Even if you're not implementing the algorithms, you still have to apply them correctly in the right sequence and get it all right. There's a lot of choices and a lot of ways to go wrong, especially in key management. So Amazon realized this, and they did some cool things. One of them is KMS, the key management service. This is your new default. And this is it. Any key you make needs to originate from KMS, or just live there, right? Any AWS service you use that stores data should have a KMS key attached. Here's what I mean by this. This is a piece of Terraform code. This creates a database instance in RDS. If I want to encrypt this RDS instance, I do this. So, not encrypted, encrypted. I add one line of configuration, and I have encryption. No excuse, right? That's how encryption works now. So by saying this, by making this point, what I really mean is there used to be a lot of conversations about encryption. Oh, I don't want to encrypt this in the database because I don't know how to do this. It's tough to get right. Where do we put the keys? It's slow. Performance issues. All kinds of things happen around getting encryption right. Those are all now myths because you can simply shove a KMS key onto your database instance and it's encrypted, right? We don't need. It takes us longer to talk about it than just turn on the encryption and be fine. Now, I would be lying to you if I said there wasn't limitations. We have to be careful about this. When you call KMS directly, you say, I want to use a key to encrypt a payload. There's a limit of 4K per message. So you have a size limit of direct KMS calls. But it does allow you to do something to alleviate that, right? KMS allows you to generate encryption keys. So have any of you worked in an environment where you have kind of a key encryption key and data encryption key? A couple people. What this means is basically you have master keys, and those encryption keys, encrypted encryption keys live in your data somewhere, right? So you're protecting them by encrypting them. So this is what we would mean by using data encryption keys. There is one tenet of generating data encryption keys that makes them better than others. Does anybody know what that is? A good source of randomness, entropy, right? KMS is backed by hardware security modules. Hardware security modules are black boxes specifically designed for doing crypto. They are better at entropy than your generic workstation is, and much, much better than a virtualized environment. So your starting source of entropy through an HSM is way better than it would be by, even bare metal, and especially by a virtual machine. So you have some advantages by doing that. So you really want to use KMS to generate any encryption keys in your environment if you're not storing them directly in KMS. So when you go down this path, I want to acknowledge the fact that data encryption keys mean you're probably going to be doing crypto in your code. But it does give you that starting source of randomness for key generation, and that is still important. So I'm going to skip the complete look because I don't know if I have enough time, but we're going to start with AWS services, right? Again, always attach a KMST to a service that stores data. It's just an important thing to do. S3 buckets, RDS instances, anything that you has the option to, the drop down or the automated configuration option, just add a KMS key, go ahead and do it. You will thank yourself later when you change your mind about that and have to go back. So add it now, right? If you move away from KMS directly because of the message limitations, still use KMS to generate encryption keys. You use that as your starting source. So a couple checklist items for encryption is all master keys and key encryption keys are stored in KMS. Now, you may have a requirement to escrow your keys, meaning just back them up. Because if something happens to Amazon and it all disappears, your data is gone forever because you're not getting it back. Key escrow is a good idea, and some of you may have requirements for that. You can still import an encryption key into KMS. So it's not just generation, you can import keys. You can also buy backup devices. So Amazon uses Gemalto's HSMs. You can buy from anywhere a HSM backup device that you can back everything up into. That's still an HSM. It's just a small little box that you use. Back it up there, shove it in a bank box somewhere, so you have those keys backed up. You can also just generate them and store them, and then use the stored ones and put them in your own little escrow. But I do actually recommend this. It is important to back them up because if Amazon goes down and never comes back up, that data is completely gone. You cannot extract those keys directly from an HSM. Any KMS key you have has the rotation option enabled. So you're going to turn that rotation on and let it go. The nice part about this, if you add a KMS key to RDS and you have rotation on, it's all going to happen transparently for you. It'll happen in the background and you will do nothing. It will just happen. So yay, that's awesome. All AWS services that utilize and store data use a KMS key. So data encryption keys are generated from the KMS master key. Again, if you have to move off, use that key generation feature. So auditing is one of our next pieces. So I have a couple of questions. My first question is, how do you know that you configure the environment the right way? How many of you are comfortable that you've done everything right configuration-wise in AWS? That's a problem, right? But we don't have to be that confused about it, right? There are tools we can use. There are free tools that we can use to give us some ideas, right? The tool I want to talk about today is Scout 2. Scout 2 is an open source tool made by NCC Group. They're a pretty popular security firm. They do some great work. Scout 2 audits configurations across all your regions and gives you a report, right? It tells you the things that may be dangerous about your environment. It produces a bunch of data, and it produces an HTML page. Looks something like this. It tells you things that you may have done wrong. In this example, it highlights things like, hey, the root account was used recently. The minimum password length is too short. Password expiration is disabled. It's giving you certain things. If you have an S3 bucket that's open to the world and world writable and readable, it'll tell you that. Those are those security issues that could have been noticed by just running this tool, right? No excuses. Run this tool on your infrastructure and see what you find. Now, one of those things I talked about at the beginning of my talk you can do today is this. All you need is read-only access. You're not changing anything. Go do this today. You're gonna have a break when you're sitting around. Grab this tool. It's a Python tool. So you pip install AWS Scout 2, and you have access keys locally. You just run this. You just type Scout 2 and hit enter, and it will produce the report. It's 2 commands. So once that happens, take a moment and breathe. After you're done freaking out, then you take some time to figure out what you want to do, right? There's a good chance you're going to be surprised by what you find. There's not been a single time I've run this on a fresh environment I've walked up to where there hasn't been something to do. So it's not all catastrophic. You may have done things mostly right, but there's a good chance it'll point out something you may not have thought about. So this is an actionable thing today you can do that'll give you a good idea of what's going on, right? This helps audit your configuration. And in fact, you can put this in the CI pipeline. You can take this and you can just simply wrap it around a script and parse the results and then fail a build if you find dangerous issues. So nice way to do a little bit of automation. In fact, if you look on my GitHub account, I have a little Python wrapper that does exactly that. And it fits in a Docker container. Steal it. That's fine. Now you might want to make it a little more robust. That's more of an example. But you could put it in CI. The next thing, though, is user activity. My second thing I want to audit. How do you know your users aren't abusing their privileges or doing something nefarious? The answer to that is CloudTrail and CloudWatch. These tools are completely invaluable. They are so important. If you're going to take security seriously, if you're going to do this right, you have to have these tools turned on, and you have to use them. These are essential tools to getting this stuff right. And what CloudTrail does is it takes a look at any API command run against the environment. So anything run against Amazon, whether you click a button or call the API, is recorded. Nobody can change that. Now you have to protect the storage where you shove the logs, but somebody can't say, "Oh, don't log that." When you turn CloudTrail on, everything gets logged. It's done inside of Amazon. You can't change how they do it. CloudWatch is customizable metrics based on other things, but you want to enable CloudTrail for any active region you have. And I will go a step further, and this is a budgetary thing, depending on what you want to do. Enable CloudTrail for all regions. Because if something pops up in a region you don't use, you may want to investigate. People, when they get your credentials, may just say, hey, you know what, I'm going to go ahead and run something in an environment they don't even see or pay attention to, right? So CloudTrail for all regions is even a better choice. And then you want to use CloudWatch to establish alerts on the big ticket items. Now, this goes way past security. This can go to performance, it can go to health of instances, it can go to kind of anything, right? But you want to establish some alerts on the important things, like maybe the root account was used. That you could definitely create a CloudWatch alert for that, and I'll go into that in a minute. Or better yet, you can actually just use a third party for this. There's a ton of things you need to be looking at and creating alerts around. You may have a small team. This may not be obvious. This is where third parties actually help quite a bit. You don't actually have to manage everything on your own. Having somebody do this is actually cheaper in most cases. And there are services provided by others that actually do this well and do this cheap. I will make one recommendation today of a company that I've used in the past and I actually really like for this. They're called ThreatStack. I don't work for them. I'm not endorsed for them. I get nothing out of this. I just really like what they do. They're really cheap and effective, and they actually ingest CloudTrail directly and give you all kinds of automated alerts, and you can set up new rules. They do a bunch of other stuff too, but this is not a commercial pitch, so I just want to say that these guys are pretty great, and I would definitely recommend taking a look at them to ingest CloudTrail, and then see what else they got. But you want to make sure to enable activity logging, and you want to create those actionable responses on bad things. So some examples might be somebody logged into the root account. You can use CloudWatch and have a single event cause an alert. What you do with that alert is up to you. You can email, you can identify a page, you can push it into Slack, you can do or HipChat, whatever you want. Like you can make this configurable. You can run a piece of code, right? Execute a Lambda function, whatever that might be, right? The root account keys were used. So they were created or used. You want alerts. A new user was created, right? You're not going to page for that, but you should probably send a note to all the administrators saying a new user was created, just so you know, right? If somebody was added to an administrative role, so somebody got admin permissions, you want to let everybody know. Maybe it's not a pageable thing, but you should send a note to a Slack channel or HipChat channel or an email, just letting everybody know, hey, by the way, this person now has admin rights. So be aware. Another thing I think is interesting is, let's say we use KMS. And, every time you call KMS, it's an API call. So all of a sudden you have, about 50 decryption events that happen in a given day. But we just reached 100 and we're climbing, right? We may want to do some alerts on that. There's a lot of decrypt events going on there. It's abnormal. Maybe somebody's stealing data, right? In previous companies, what I've done here is I've actually used that to execute a Lambda function that disabled that encryption key for now until we figured out what was going on. So cut off the pipeline so they can't decrypt anymore. So if somebody's stealing, they can't steal that much. So it's exfiltration protection. So something that happened recently, so this is kind of a development that happened over reInvent at the end of November, early December, was Amazon came out with a service called Guard Duty. Guard Duty actually does some of this stuff for you. It actually is continuous monitoring, and it gives you analysis of potential threats, right? So when you turn CloudTrail on and you have a bunch of information going on, your flow logs and VPCs, Guard Duty is going to watch this stuff and let you know. So Guard Duty is another option. Now, I haven't had a chance to use Guard Duty in anger and in production. I've only been playing with it, so I can't recommend it's as the best thing to do. But I can say, Amazon does pretty good with this stuff, and I'm pretty hopeful that it's going to be a pretty great service. So my checklist for auditing is configuration analysis. You do this daily, right? You have a nightly thing that runs and just says, hey, what's going on? Scout 2, tell me what's up. Did I do anything wrong? Or you do it on every change. That's the better way, right? You want to do it on every change. I'll talk about CI in a minute. CloudTrail is on for all active regions. I would also recommend doing it for every region, but remember that it costs money. CloudWatch metrics and alarms are implemented for any major violation cases, right? The things I talked about are examples, but anything that is important from a security aspect and also from performance, right? How many of you think that availability is a security concern? Right? Every hand in this room should be going up. If you have an outage, what do you lose? Money. If you have a security event, what do you lose? Money, right? You have a loss event, right? An outage is a loss event for the company. The business loses their ability to function. That's a loss event for the business. That is a security concern. Performance goes hand in hand with everything else, right? If you're out of CPU, if you're out of memory, if you're out of disk, and you go down, it's a loss event, right? You want to treat that as a security concern. So put that stuff in there too. It's important. And then Guard Duty, right? Still, the verdict is still out, but I would definitely recommend playing with it to see if it's valuable for your environment. All right, CI. So we talked about a bunch about automation, tooling, all this stuff, right? How do you automate it? I want to automate the automation, right? So I have some base automation about how I do things, but I also want to have some initial automation that checks to see what I'm doing and making sure I'm not doing anything, wrong. Once your stuff is in code, so all your infrastructure's in code, everything's kind of talked about in that same language, you can hook it into CI, right? That's the next natural step. Every time we write code, we should be putting it into some kind of test process that goes through CI and eventually pushes a button, right? And in fact, when we think about this, if the end of CI is pushing that button to do that deployment or build that artifact, it can also trigger Terraform or CloudFormation or Ansible or whatever we want to use, right? So the end of that pipeline could be that nobody ever actually runs the deploy script. It's just the CI pipeline that does it, or CD pipeline, whatever you want to call it. So now you can block or you can roll back changes based on what your CI pipeline finds. So you can just say, oh yeah, well, I have this thing, static analysis said, oh, that's a bad idea, or I had a security group going out and it didn't have a tag. So let's go ahead and roll that. And it was access to the world, right? So I can just put a rule in place, a simple little rule that says, oh, we have a new security group, it's open to the world, and there was no tag applied, so reject that. Just stop that now, make sure there's a tag in place. So just simple little tiny checks that give us a lot of power. You can do seamless sign-off policy, right? That lives in where you host your code. And this is important because what we're going to do is create a couple barriers. We're going to slow things down, but we don't want to slow them down for any real reason, and we don't want to slow them down for very long. So we'll put this in the workflow. An example of this, this is something I did at a previous company. We just put it in GitHub, right? So you put it in GitHub. We protected the master branch. The master branch is what got deployed from. You couldn't push the master branch directly. You had to do it via pull request. So there's a bunch of stuff had to happen before that was possible. And so some of those things were that, the build had to pass. There was code climate to make sure it wasn't, completely insane. And we had a bunch of our own custom checks that ran to make sure nothing crazy happens, right? And so we had a little interface for it that looked like this. So we would check for things like it was linked back to a ticket. So there was some kind of, reason why we made a change. That that we didn't disable SSL somewhere. That it was peer reviewed. That if it had a migration in the database, that somebody approved it. If it had permission changes, that security approved it, right? We actually put different people approving different things in the whole pipeline to make sure that there was a sign-off process somewhere along the chain that meant somebody reviewed this. But we made it seamless and we made it simple. Now, once you do this, you create a blocker. You create a hard block because you're involving people. So when you do this, or if you do this, anybody listed on that chain should be mercilessly spammed in company chat until they hit the button, right? Don't let this pass and expect somebody to just do it, right? If you do this, set up some integrations with Slack or HipChat that say, hey, by the way, we're waiting for you every 5 minutes until they make a change. Bug the hell out of them. Because once you do this, once you slow people down, the pitchforks come out. So make sure people know that they need to review things and prod them mercilessly until they do it. It's an important cultural thing. So, for CI, all changes trigger configuration audits. When you change the infrastructure, it runs an audit. It's part of what we do. Critical issues that are found in CI trigger some kind of response, right? Some of these tools, right? Terraform, for instance. You got to apply Terraform before you can audit with Scout 2. The change has to be there before Scout 2 can figure out what happened. So you may apply, and part of that may be apply, audit, and then roll back if you found something bad. So it may be part of that whole delivery pipeline where you have kind of it's your sanity test, your smoke test. Okay, I deployed. Is it saying, all right, we're good? So that last step before you consider yourself done would be that audit. So you may trigger a response like a rollback. Use that CI pipeline to create that sign-off process. The whole point of this, the whole point of going to the cloud, the whole point of doing this is to move faster, right? Move faster, make it easier, be more productive. Use that pipeline to move faster, right? You're going to have a couple blockers here, but you don't want to make real concrete blockers that last too long because now you're back to where you were, right? Don't revert back to where you were. Maintain control, but use a nice pipeline with a lot of automation to get all the checkpoints and sanity you want. The benefits of doing this, right? The benefits of being on a cloud provider of some kind, they're massive. These are a bunch of serious gains. Some of the tools I talked about today, especially the HSMs, those hardware security modules, this is $1 million investment from scratch, at least, right? It's a lot of money, and it's a lot of operational knowledge, tribal knowledge. There's a lot of stuff that goes wrong with HSMs, and when they go wrong, your data's gone. And so just operating HSM in general is a really, it's a tough proposition. It's cheap on Amazon. It's a few cents, here and there. So doing that is incredibly powerful, right? Being able to encrypt a database with, a line of code is really powerful. Knowing where your stuff is at, right? Just what's your inventory? What are my servers and what are they doing? That's really powerful too. Just asset inventory is part of security as well. So there's so many things that this gives you that are kind of just part of the platform. They're free. You get them for, just using the platform. And some of them cost a little bit of money, but way less than you would if you did it on your own. So if there's a fear of shifting, right? So some of you that raised your hand and said you can't do it yet, there isn't a good reason to. People are afraid that security is not as good as it could be in the cloud. You should look again. At this point, the cloud is not as safe as my data center. It's complete FUD. Nonsense. I will absolutely put my stuff in AWS over a data center any day. For some of the reasons I described, and a whole bunch of other ones that I won't. If you're audited by some regulatory body, PCI, HIPAA, FFIEC, any of these big audit firms, right, or regulatory firms, this is going to help you a lot, right? Because one of the things they're going to ask you is, where are all your servers and what do they do? Well, I can write a script that tells you that, right? All that automation you just made can be used to just produce reports for auditors. You hit a button and get audit reports. You're just by doing this, you're kind of putting all the auditability into what you do. So that's a huge benefit as well. So healthcare, finance, government, all of these industries are doing this already, right? I was formerly a CISO at a healthcare company. The whole thing was at AWS, all of it. We passed every compliance, every audit, flying colors. No exceptions, no reports, no corrective actions. They were good. In fact, they said, hey, this is better than what we've seen, anywhere. And they were amazed at the ability to just produce data consistently and easily. They're like, oh, well, give me a sample size of 25%, and that's going to take a lot. No, here's the whole thing. Just hit a button, right? And it was built out of all the automation that's just existing there, right? So people have done this. They're already doing it, right? There's no reason not to make this leap for security. There may be plenty of reasons not to make the leap for finance, for economic reasons. I'm not saying it's the best thing in the world. It's prescriptive to your environment. But for security, right? They're doing all this stuff. And in fact, I think you're better off heading down this road. And with that, I'll take some time for questions.